Hello everybody. In today's video I'm gonna continue with the exponential equations, and in this video I'm gonna show you how to solve the exponential equations by substitution, and how you can realize that it's really good to solve the equation by substitution. So let's solve the equation 3 to the power of 2x. Take away 3 to the power of x equals 6. As you can see, you were taught till this video that it's a kind of good idea to think about it like 3x times 3x minus 3 to the power of x times 3 to the power of x, take away 3 to the power of x equals 6. But in this case, if you would take the common factor in front of the expression, and then you will remain with this expression in the parentheses. And if you have a look at this one, I'm pretty sure you will realize that it doesn't make sense to solve this equation by factorization, because you are not able to solve this equation very easily. But there is one more tricky thing, and it's called substitution. So instead of doing this, you can think about the first term, like 3 to the power of 2x, and using this formula you can write the first term like 3 to the power of x squared minus 3 to the power of x equals 6. And if you have a look at this equation, you should maybe remember that there is a good way how to solve this and how to simplify this equation so that you can solve it by well-known methods. And in this case it makes sense to make like a new variable, which is for example u. Simply, it doesn't matter how you name the variable, and you say that your u is equal 3 to the power of x. And if you substitute 3 to the power of x with the unknown u, in this case, you will get the equation u squared minus u is equal to 6. And this is something which you can solve very easily, because if you have a look at this equation, you can simply see that this is after the operation take away 6 from both sides. You will see that you will get something which you really already know, and this is our quadratic equation. And you are now able to solve this quadratic equation by using the discriminant or quadratic formula. Or if you want to, and this is much easier in this case, you can use the factorization method, which says that you are supposed to find two numbers, so that if you add them up you will get the number -1, and with the same numbers, if you multiply these numbers, you should get -6. Now you look what are the factors of number 6 basically, and these are like 1, 2, 3 and 6. So you look for the proper combination of these numbers, but you should keep in mind also that this could be not only positive numbers but as well integers. As you will see, the best choice for us now is to choose -3 and +2. Because -3 plus 2 is -1, and -3 times 2 is equal to -6, which means you can now simplify the quadratic equation, like u take away 3 times u plus 2 is equal to 0, and as you already know, the factor of two factors is equal to 0 if one of them is equal to 0, which means u must be equal to 3 or u must be equal to -2. So these are the solutions for our quadratic equation we got from after the substitution in our very first equation. Now, this is not our solution because the task says solve this equation, which means you are looking for values of x so that this equation is true, and based on the result you got from solving the quadratic equation and this substitution, you now know that if u is equal to 3, then this equation will become like 3 equals to 3 to the power of x, which basically means that this is if and only if x is equal to 1, because 3 to the first power is equal to 3, and with using this fact that the exponentials are equal if and only if the bases are equal, then the exponents or indices must be equal as well. So this is our first solution. The next solution is coming by using u is being -2, which means -2 is equal to 3 to the power of x. And if you think about this, then this statement, if you want to use it like this, is false or is not defined for any x, because if you sketch the graph of the function, exponential function 3 to the power of x, we already know that the graph of this function is such a line, and we already know that the domain of this function is the interval from 0 to the infinity, which means the y values or the values of our function are from this interval, and because -2 is not from this interval, then there is no there cannot be any x found, so that the equation is true. That's why we make the conclusion of the sets of the solutions of this equation, or roots if you want to, that it is again one element set, and it consists, or it there is only number 1 in this set, like the solution. Now the good thing would be to make the check, but let's do the check like very quickly. So left side for x being 1 is equal 3 to the 3 squared minus 3, which is equal 9, take away 3, and this is of course 6, which is good because our right side is equal to 6 as well. So our solution x equals 1 is fine, and basically the only one solution of our equation. Okay, let me show you one more example like this, and we will come to some conclusion which is gonna be a little bit different, and I'll explain why. Okay, so our next exponential equation is like 10 to the power of 2x take away 1 plus 10 to the power of x is equal to -2.5. Please don't be scared of these numbers. This is decimal. I know some students don't like decimal numbers, but during my solution you will see that this is like okay number for this equation. So what I didn't mention during the solution of the first equation, how can you realize and how can you start thinking about the substitution method when using the exponential equation. And there is one let's say difference or sign which indicates that probably the substitution will be very good method is that you have some kind of base here, then you can realize that the same base is like to the second power of x or whatever, and then there comes some number which has nothing to do at the first point of view with the base of 10. So in this case you try to rearrange your equation like 10 to the power of 2x times 10 to the power of -1 plus 10 to the power of x is equal to -2.5. Basically what I wanted to say also is that if you don't know what to do with the first equation, you start to play around with the equation, and maybe you will come to some expressions or even the equation on which you will realize that, oh, okay, this is something I already know how to solve, and then you will be like on the good way to find the solution of the first or of the given equation. So now if you have a look at this one, this is something we already saw in the previous example, and 10 to the power of 2x can be again written like 10 to the power of x squared times, and now I'm gonna use the fact that the 10 to the power of -1, which is already mentioned here, is 1 over 10 plus 10 to the power of x is equal to -2.5. Again, here we come, and here we see that this is like let's say common factor, but in this case we don't gonna use the factorization, because as you saw in the previous example, this will not help us to find the solution of this equation. So basically you can realize that this is something, if you want to, this is something squared plus something the same, and it means that you can again use the substitution method, and in this case let's use again u as notation for our unknown variable, and u will be equal to 10 to the power of x, which would then lead to the equation u squared over 10 plus u is equal to -2.5. Now we want to get rid of the fraction, which means we multiply both sides of the equation by number 10, and here you can realize that it's gonna be really okay, this number, because it will come like the integer, and it's gonna be -25. Again, plus 25, we will rearrange our equation, u squared plus 10u plus 25 is equal to 0. Now, this is one of the reasons I have chosen this equation, because you could, and it's like coming when you will be solving, and when you solve quite a lot of quadratic equations, you can see that this is something which we call like perfect square, because we can write this quadratic expression as u plus 5 squared is equal to 0, because this is our very well known and very or oftentimes used formula: a plus b squared is equal to a squared plus 2ab plus b squared. And if this is true, then b must be 5, and if you think about it, it really fits for our expression on the left side of the equation. So it is really perfect square. And as you already know, this is true only if and only if u is equal to -5. There is no other solution of this equation. Now let's go back again to the substitution. We made the substitution, so we substituted 10 to the power of x by unknown u, and having in mind or connect these two facts together, it would mean that negative 5 is equal 10 to the power of x. For the same reason as you saw before, the graph of our exponential function 10 to the power of x looks like this. We already know that there can be only positive values for y variable, and it means that this equation doesn't have any solution because this statement is not true or not defined. Okay, so what is the conclusion then? Is there any x that fits, or that is the solution of this equation? Yes, if you said no, then you're right, and it means that the set of our roots is equal to the empty set. So there is no solution for the equation 10 to the power of 2x take away 1 plus 10 to the power of x is equal to negative 2.5. Okay, so these were like two examples, like quite easy examples how to solve the exponential equations by using the substitution. Thanks for watching, and see you during our next video. Bye.